Hey, good morning. Nice to see a good crowd here. And so somebody just asked where's the CXL switch, and this is a topic we're going to cover. We're going to talk about enabling composable, scalable memory system for AI applications, some AI usage case. So just briefly, my name is JP Jiang. I'm from a startup company called Xconn Technology. So anybody who have been working with the CXL, they probably know Xconn because we provided a switch, a big capacity 256 lane switch. And today we're going to talk about this topic together with H3, which is our partner, and they did a lot of great work in this area. So the CMS stands for Composable Memory System. This is a subgroup inside OCP that in the past years have done a lot of great work to put together a memory system that targeted for the AI application. So this is a brief kind of diagram of the CMS system. So some background, I think Manoj and Samir, they have talked extensively about how to utilize all this memory system in the AI application, and we can, understand the memory access or memory usage in these AI system are pretty hard, right? So in the one hand, you need a very high bandwidth. On the other hand, you also need a very high capacity. So, and also CMAC also talked about, CXL, how that get into the system as, beyond the HBM, and also the secondary memory or the extended memory. So this diagram shows generally, it's a computing architecture where the composable memory get into the play, especially because all these computing systems are getting a lot of usage. We imagine in the next few years, once the AI application really take off, you will see a lot of data center that running all these AI inference, not only just a single host, but multiple computing nodes. So we could call that, AI inference computing farm or something, right? So definitely this is going to really scale. Although this picture just shows one computing node, you can really imagine in the next couple of years, they're going to really explode, because in the past we were taken by the surprise how the AI really accelerate, right? By 10x every 2 years, the pace like that. So we're a little bit also forward-looking, try to put together some work that really targeting a little bit into the future. So the composable memory system here, I want to point out, when you talk about to be scalable, a switch is really the way to go, because a switch can really connect multiple computing nodes, and then also connect a big, very huge pool of memory resource, being that CXL memory at this point. And people come up with a lot of ways to take advantage of this huge memory pool capacity, right? So Xconn, we are pioneering a CXL 2.0 switch as of today, and that chip is kind of in the mass production stage. In the OCP exhibit floor, you will see multiple demos. We have one rack, one big rack, 42-inch rack that has 2 servers and a big pool of memory up to 12 terabyte. That's in collaboration with multiple customers. For example, Micron, Cradle technology, and Memverge, and all these ecosystem partners. So here I'm showing a single node that with a CXL switch, you can put together a chassis or a basic building block of this composable memory system, where you have a switch and you have a couple ports that connect to the host, and a number port connect to the CXL memory devices. Again, because you need to be scalable, we do provide this scalability where even at this stage, CXL 2.0, it can make the cascading work. So this is showing a two-level switching, cascade switching, right? So if we take this into a composable memory system and use that into the AI application, you would see some picture similar to this. So the computing nodes, we say it's inference, but it could run in any other kind of AI workload. So you could have a multiple AI computing nodes on the top of this fabric, where the fabric is composed of multiple switches. And underneath this fabric, you can attach a very huge pool. So here we're talking about tens of terabyte or even hundreds of terabyte, because today we're at CXL 2.0, but our switch CXL 3.x is coming up next year. And with 3x, you basically can connect thousands of devices into this bigger pool. So then we are really talking about hundreds of terabyte and really scalable to a very big computing architecture. All right, with this, I will hand that to Brian to talk about some of the work he has been doing. Thank you.
Thank you, JP. Good morning, everyone. My name is Brian. I'm from S3 Platform. And the switch system is finally coming. We have based on the Xconn switch to build up the systems. And that systems, we have the 22 E3.S for 4 hosts. So this is the lab settings in our lab that we use 2 Intel EMR servers connected to the memory systems. Of course, the system with the Xconn's CXL switch. And then we do 2 different things. If we assign a single memories to the different hosts, then we call it pooling. And we also can do the single memory assigned to 2 hosts, and then they can access concurrently to do the sharing. So later I will show you the testing result. We have do some testings. So here is the testings. If you see the pooling, if you assign 1 CXL memory to the server 1 and 1 memory to the server 2, and you do the SS is roughly like 27 gigabyte per second. If you use only 1 CXL memory assigned to 2 different hosts, and then we use the Intel MLC 3.1 to do the max bandwidth test. And all the tests, at least we run 10 minutes, and then to get it steady state. So the number that you got is that if you do the sharing, you got 13.5 gigabyte per host. So it's evenly distributed to the 2 different servers. And we also do some of the expansion tests. But this expansion test is going through the CXL switch again. So it's a switch attached memory. So we have do the first is string test. If you do the string, we do the interleaving. You see on the left side is the DRAM interleave. There's a 2 socket CPU, right? So each socket have its own 32 gigabyte DDR. And then we assign one 256 gigabytes memory. And then we do the interleave. So you see that if you use the higher CXL memory, you got better performance, roughly like 30% more of the bandwidth compared to DDR only. We also do one HPC's OpenFOAM. OpenFOAM is a computational fluid dynamic. I think it's one of the HPC's usage models. So if you see that if you have more CXL memory, then you see the performance increase as the memory increased. So we have been developing this system over like 2 years, and then we have built up two different 1.1 and 2.0. In 1.1 we use ML Rapids, and then of course the switch simulate a kind of end device for the EMR servers. And then we got a very key milestone to develop CXL 2.0. We have successfully built up the virtual CXL tree for the host. So we use the AMD's Turing servers. So Turing server can see the virtual device that we create by our management CPU. So currently we have the 4 devices or 8 devices. Then we bind real devices, real CXL memory modules to that virtual device to do the access. So I think it's next time that I will bring up the real CXL 2.0's implementations and get some of the data. So during the almost the 2 years developments, you can see that we have so many challenges from the OS, from the driver, from the device side, from the switch side, everything. So we really needed a whole industry to support. For example, like if I take the OS as example, if you have used the CXL memory, if you use as a kernel module 6.2 or then you see it as a DEX driver, but 6.3 or beyond, they finally get a DEX driver as the CXL memory. So the behavior will be different. So we have lots of different things that go through that how we use the memory in the OS environment, how we use it in the application environments. So we need people to help us to solve that kind of issues. And then of course we would like more people to use it, and down the road to get more and more applications for that CXL solutions. Thank you. That is my presentation. Any questions? Yeah, please.
You spoke about OpenFOAM. Would you happen to have any other AI-centric, Llama-based centric workload?
Sorry. Yeah.
Distributed over multiple memory controllers or CXL using switch?
Yeah, this part I just Samir's show it because originally one of our partners want to do that for us. Unfortunately, it takes too much efforts to really build up a real environment to do it. So that's why I do not show it, but sorry, the topic that we say we want to do the AI or inference, but in fact we are building that. But they probably next time that I will show that kind of applications.
There's something I don't understand. You're saying that you support memory sharing, but my understanding is CXL 2.0 does not support memory sharing.
Yeah, good question. In fact, the memory sharing in the 3.1, they use MLD devices to do the sharing. I mean, in the standard Linux and a standard spec. What we do is that, in fact, we do the proprietary way to mapping the device to the 2 different hosts at the same time. We don't really lock the data. We don't do that kind of thing. We just mapping the 2 devices to the 2 hosts. So the testing that I just show is to the read, 2 CPU read at the same time.
Yeah, of course you don't lock the memory. The CXL does not, in sharing memory, it's not involved with locking. But my question, the problem with the 2.0 server and the 1.1 server is the way they issue the memory requests. There's a deadlock possibility if you share memory. So how do you avoid that? You have no control about the way the servers do the load and store.
Okay. So because we are the switch side, so we assign them both to then the people need to use. Currently, we work with FAN FS. They use the file systems. the distributed file system to control that kind of lock, of a data lock, because that is the way that they can use.
I see.
Yeah.
Okay, one more question is,
Yeah.
you're talking about 3.x functions, but
Yep.
you need a 3.1 server, and I'm not aware of Intel or AMD even making a server under NDA. Is that right, or is it?
It's not yet. I think it probably 2026.
So somewhere in your presentation, you talked about the switch can give 3.1 features, but there's no way to use it, right? How do you use it? Like a dynamic capacity device, nobody makes a dynamic capacity device. So how do you use those? You can't use those things yet, is that right?
No, it's wait a moment. In fact, the whole implementation of the CXLs, you probably can take some of the features from 3.1 to 2.0, but there's some proprietary implementation, but there are some limitations.
I see.
Yeah, that's the whole thing. I think about the DCD, we are talking to the kernel team, and to use the DCD team's kind of ways, give them usage case, how our implementation can do, and whether kernel memory management team can accept that kind of a way to do it.
Yeah, okay.
Yeah.
Yes, I think it was from Jianping's page. I'm not sure if whose page was that, but you showed me Intel MLC 3.1 bandwidth score, right? So
Yep.
in pooling cases and then sharing cases, sharing bandwidth actually dropped by half. So why is that the case?
You mean the?
Yes, pooling servers bandwidth is 27
Yeah.
gigabytes per second, but sharing is about just half of it.
Yes, it's because to access the same memory, so it's only like 27 divided by 2 hosts, right? So it's a PCI Gen 5 by 8.
But I was assuming that two servers are accessing the same data memory region sequentially, right? Not
Concurrently, we do it concurrently.
concurrently.
Yeah.
But really, okay.
Yeah, we do it concurrently.
So
Yeah.
if you access the same data sequentially, sharing the data, then the bandwidth doubles.
Yeah, suppose, but because we do it concurrently, so it's only the Gen 5 by 8 option. Yep.
Okay, thank you.
Thank you.
I just want to make a comment on the previous question that was asked from this side.
So yeah.
What I would say is the dynamic capacity device is possible with CXL 2.0. I have seen implementations of that. Maybe there is some customization required, but we do not have to wait for 3.1 CPUs for dynamic capacity device.
Thank you, Samir. Especially the OS expert.
Yeah.
Thank you.
Okay.